When you look out the window of a speeding train, the world outside is a blur of motion. Trees and telephone poles rush past the glass in a continuous stream. But inside the cabin, the perspective shifts. Your fellow passengers are sitting in their seats, quietly reading or sipping coffee, appearing to be perfectly still. This raises a question. Who is actually moving? Is it the trees outside, the train itself, or the observer? The answer depends on your perspective. Motion is relative, rather than a fixed or absolute state. An object is only at rest or in motion when compared to something else in its immediate environment. To define that movement, we have to establish a reference point. This is a fixed object or location used as a baseline to measure every other distance or position. In a park, using the central fountain as a baseline, you are exactly 10 steps to its right. Choose a nearby bench as the new reference point, and your spatial description changes. Without moving, your position is defined by a new distance and direction. This applies to the largest structures on Earth. Compared to the streets of Dubai, the Burj Khalifa is stationary. However, if we change the reference point to the sun, that same building is traveling through space at 67,000 miles per hour as the Earth orbits. Because every single object in the vast universe is moving relative to something else, absolute stillness simply does not exist. Without a reference point to act as an anchor, the concept of position has no meaning. Once a reference point is selected, we can categorize the physical patterns dictating how objects travel. The most general category is translatory motion. This is the term for an object moving entirely from one location to another. If that travel happens in a straight line, it is called linear motion or rectilinear motion. You see this when a car drives straight down a highway or a train travels along a straight track. If an object moves along a curved path around a fixed center, it's in circular motion. This is how the Earth moves around the sun. The sun is the fixed point, and the Earth follows a continuous circular path around it. On a smaller scale, the same pattern applies to the blades of a ceiling fan as they spin around the central motor. Whether it's traveling in a straight line or orbiting a center, these categories describe how objects physically navigate from one point to the next. Some movements are defined by time. Periodic motion is movement that repeats itself at regular intervals. A healthy heartbeat is periodic. It follows a steady rhythm that repeats on a consistent timer. Oscillatory motion is more specific. It describes an object moving back and forth around a central resting position. Think of a playground swing or a clock pendulum. They physically swing out, stop, and return through their center point. This Venn diagram shows how these motions relate. Every oscillatory motion is periodic because the back and forth swing repeats on a timer. But not all periodic motion is oscillatory. A heartbeat repeats on a timer, but doesn't swing through space. While many things follow a timed rhythm, only objects that swing back and forth through a central point are truly oscillating. In our daily environment, objects rarely follow just one type of motion. Most things combine these patterns. GPS navigation relies on these principles, establishing constant reference points to track the linear motion of a car during a trip. Professional sports offer even more complex examples, like a cricket bowler throwing a spin ball. As the ball travels down the pitch toward the batter, it exhibits linear motion. At the same time, the ball is spinning rapidly around its own axis, which adds a layer of circular motion to its flight. Look around your room. Try to identify the reference points and the specific types of motion governing the objects nearby. From a falling leaf to a spinning wheel, you can now identify the specific patterns and baselines that define every movement in your world.